Hey everyone, welcome back to the channel. How's it going? My name is Jyotinder and I do LeetCode questions on YouTube. So if you're into that stuff, be sure to check out my channel. Right, so today we are looking at a problem that is called merge intervals. So given a collection of intervals, you're supposed to merge all the overlapping intervals, right? So you can imagine a number line and you're given intervals on that number line. And you have to merge all these intervals which overlap with each other. What do we mean by overlapping? So let's say they've given us an example here. So you have a vector of vectors and each of the vectors inside this entire container represents an interval. So you have the first interval given as 1 to 1, 3, the second interval given as 2, 6, the third one as 8, 10, and the last one as 15, 18. And now you're supposed to merge all the intervals which intersect with each other or which overlap with each other. So what we mean by that is, when do two intervals overlap? Two intervals are said to overlap when the ending time of the first interval is greater than the starting time of the second interval. So if you look at the example, you have the first interval as 1, 3 and the second one as 2, 6. You see that the first interval ends after the second interval starts, right? So 2 is smaller than 3. So you see that the second interval already starts before the first one has ended. So you can actually merge them into one single interval. And you can merge them and you get the interval 1, 6. Starts at 1, ends at 6, right? So that's what you're supposed to do. And you're supposed to scan through the entire array and you have to simply keep merging all the intervals that overlap, right? So how do we solve this problem? It's not actually a very difficult problem, and once you get the concept, it's really not that difficult. So the first thing is, you cannot assume the intervals to be sorted in any sort of manner when they're given to you. So you need to do the sorting yourself. Why do we need to sort them? Well, it's just that if you sort them, it becomes a lot easier to merge them, right? So you only have to compare consecutive intervals all the time. You don't have to look anywhere else in the array, and it really just helps with the time complexity as well. So it's always better when you have to just compare consecutive or neighboring elements rather than having to compare some random elements in the entire vector, right? So the first thing that we'll do is we'll sort them. But what will be our sorting criteria? You can't just sort them with the inbuilt sort method, but you'll have to define a custom sort for this. So how will we define that custom sort? Well, the way we want the elements to be placed or the intervals to be placed is that the intervals with the smaller starting time need to appear first, right? So let's say we have the interval 1, 3. The starting time is 1. It's the smallest among all of the intervals. So we want this to appear first, right? So it's a lot easier. If you have the interval that starts first, then you have the interval that occurs after that, and then you have the interval that occurs after that other one, and so on and so forth. So it's always easy when these are sorted according to the start times. But you might also face some conditions where the intervals have the same start time. What do you do in that case? You have to define a condition for that case as well. And in that case, you have two options. Either place the one with the smaller end time first, or place the one with the larger end time first, right? So it depends on you how you want to do that, but I think placing the one with the smaller end time first makes a lot of sense, as well as it kind of simplifies the implementation a bit, right? So yeah, so let's say you have two intervals that are 1, 3 and 2, 6, right? So if you want to sort this and you want to see which one appears first, you'll see that the first interval has a smaller start time, so you want to place this one first, right? And the second one has a larger end time, so you want to place this after that. Now in case this was something as 1, 3 and 1, 6, in case they had the same start time, you want to place the one with the smaller end time first. Why do you want to do that? It's no real reason there, right? So you can do it the other way around. You can place the one with the larger end time first as well. Might just change just a few things in the implementation, but not really a big difference, so you can do it either way. What I'll be doing here is I'll be placing the one with the smaller end time first, right? So yeah, that is one thing that you need to take care about. Now, how do you actually merge these intervals? So let's take another example. So imagine that you have the time intervals 1, 10 and let's say 3, 5. Now if you want to merge them, you see that these are overlapping intervals. Why are they overlapping? Because the end time of the first one is greater than the start time of the second one, right? So you know that these intervals intersect. Now, we know that the resulting interval will obviously start at 1 because it is the starting time of the first interval, and we know that we had already sorted this array with respect to their starting times. So we know the smaller starting time appears first. Now, what will be the ending time of this interval? The ending time will be the greater of the two ending times of the two intervals, right? So you have the ending time as 10 and you have the ending time as 5. Which of these is greater? Because when you merge them, the ending time of the resulting interval will be the one which is greater than the other interval, right? So if you have 1, 10 and 3, 5, you see that 1, 10 ends later, right? 10 ends after 5. So you say that when you merge them, you get the interval 10, right? So if you merge them, you just get the first interval, which is this. In case this was something else, in case the second interval was something like 3, 15, in this case, what you do is that you'll see that the larger end time is in the second interval, right? Because 15 comes after 10. So if you merge these two intervals together, you'll see it still starts at 1, but now the ending time is 15, right? So the resulting interval will become 1, 15, right? So the start time is always the start time of the first interval, and the end time is always the larger of the two end times of the two intervals that you're trying to merge, right? I think it will become a lot more clearer when we start coding it out. So let's just get into the coding part now. All right, so the first thing that we'll do is define the sorting criteria. We already talked about how we'll sort these, and we just need to define a comparator to bring that into code. So let's say we define a comparator called comp. The type is auto, so that it just infers the type itself. And we define a lambda. A lambda is nothing but sort of like an inline function, right? So you can read up about them. I'll probably include a link for that in the description. But if you just look at this example, you should understand how these work. So the first element that we'll be comparing, we'll call it A. And the second element that we'll be comparing, we'll call them B, right? So whenever you are sorting, you always compare two elements at a time. And let's just say that we call the first element as A and the second element as B. The ampersand sign just tells you that we are passing them by reference so that we don't create any unnecessary copies. Right, so we have two cases here. The first one being when the start times are equal, and the second one being when the start times are different. So when the start times are equal, you just say if A of 0 equal to B of 0, so that when the first element of both the vectors are same, which is for the first element is basically the start time. So if the start times are same, we want to place the one with the smaller end time first. So we'll just return A of 1 smaller than B of 1, right? So this just needs to return true when the end time of the first element is smaller than the end time of the second element. In case that's not the case, it will return a false and we'll have to perform a swap, right? In case the start times are different, you'll simply return true when the start time of the first element is smaller than the start time of the second element, so that the one with the smaller start time gets placed first. So you'll return A of 0 is smaller than B of 0, right? So this is your comparator. Let's just place a semicolon here. Now you need to sort this entire vector of vectors. So we'll just do sort intervals dot begin intervals dot end and just pass in the comparator here, right? Like so. So now this entire vector of vectors will be sorted for you using this custom comparison condition that we defined here. Now we need to start iterating through this array, right? And before we do that, let's just define a resulting vector as well. So we'll just say vector int, and I'll call this res. Now we need to start iterating through the intervals. So for int I equal to 0 while I is smaller than intervals.size plus I, and yeah, right. So now what we have to do is that whenever we start adding these intervals to our resulting vector, right, and whenever we get a new interval in our hand, we need to check, is this new interval mergeable or is this new interval overlapping with the last interval that we pushed inside the resulting vector, right? If that is the case, then we'll merge them. Otherwise, we'll simply push this new vector inside, right? So we'll say if the resulting vector is not empty, if it's not empty, and if the ending time of the last element that we pushed inside the result, if the ending time is greater than the starting time of the current interval that we're looking at, then we need to perform a merge. So we'll just write this as res.back. This will give us access to the last element. If the ending time, which means the first element at index 1, if the ending time is greater than or equal to the starting time of the interval that we are currently looking at. So that will be interval I 0. So if this is the case, if the ending time of the last interval pushed into the resulting vector is greater than the starting time of the current interval that we're looking at, we need to perform a merge. And we know that the starting time of that interval will simply remain as the starting time of the interval that was present before, right? So if we are merging these two intervals, the starting time will obviously be the starting time of the first interval. So we don't need to change that. We just need to change the ending time, right? So we'll just write res.back1, which just defines the ending time. So we just need to change the ending time, right? This will be the ending time which is greater amongst these two intervals, right? The interval at the back of the resulting array and the current interval that we're looking at. The one which has the greater ending time, we'll be using that as the ending time of the new interval, right? So remember when we had something like 1, 10 or 1, 20 and 3, 5. So we saw that the greater ending time was the one that we were using for the resulting merged interval. We'll just write intervals I 1, res.back, 1, right? So whichever of these is greater, we'll use that as the ending of the merged interval. In case they were not mergeable, we'll simply push this new interval into the resulting vector. So we'll just write res.pushback and we'll just push this interval inside. So we'll just do intervals I and this should be it. Now, so this is the entire algorithm and we'll just return the resulting vector, right? So we just sorted this vector first. We sorted these intervals based on a custom criteria. Then we defined a resulting vector. After that, we checked if the resulting vector is not empty. Then we check, is the current interval that we're looking at index I, is this mergeable with the last interval that we pushed inside the result? So when are they mergeable? They are mergeable when the ending time of the earlier interval is greater than the starting time of the current interval. So if that's the case, we define the ending time of the new interval as the ending time amongst the two intervals that we're looking at, which is greater. And so we use a max here. In case they were not mergeable, we simply push in the new interval back into the resulting vector. And then we return that result back to the caller. So let's run this and let's hope that this runs. And it does. So 44 milliseconds, 78.2%. And that is how you solve this problem, right? So I hope you enjoyed this video. If you like this, do hit the like button and subscribe to the channel for more content. And I will see you in the next video.